Suturing started 8 years ago. We've been designing a medical device that does sutures, stitches. At the moment we're on the prototype stage. We've been doing all of our prototyping with the Form 1 Plus. We normally have about 50 parts inside this tiny component. So with 3D printing, you can work out an aspect of the components that are going inside, print it within 3 or 4 hours, change it, reprint it, change it. I've had it where I've had 3 prints in one day. In the conventional style, the way that we were doing it beforehand would have taken 6 months of getting outside, printing, getting another source, and then getting it back in again, doing the redesign. It was taking about 2 weeks as a turnaround. This was taking 3 hours. So it was about 6 months of work in a week. We had one set of components that we knew had cost us £100. With our own printer, I think it came to £3.40. So it's a big difference. 4 years ago, I came to the Royal Brompton Hospital asking for somebody in medicine that we could work with, somebody experienced. We were passed on to Mr. Richard Trimlett, who's one of the consultant cardiac surgeons here. We've been working with him for the last 4 years. He helps with the design end from the user perspective, and he's now doing all of our trials and testing.
Conventional suturing, you're responsible for the rotation of the needle through the tissues, and that can often be a challenge because the angle at which you may want to rotate may not be in line with your instrument. You may not be able to access it. Whereas this, the needle follows a perfect arc. This is neater and more efficient.
But also less likely to cause tissue damage. And tissue damage there can lead to wound breakdown, infection, hematomas and so on.
Okay, so this is the large head for our larger handheld device with a 48mm needle that goes inside. Inside the head there are a series of components that drive the needle. These ones are a combination of metal and plastic. Underneath we have a series of gears that drive all of these rollers that drive the needle, and they print at the 25 micron level. And all of the other components we print at 50. So it's more than accurate enough. 3D printing to this level of accuracy costs a lot of money. To have something desktop where it's within the price range of an individual creator, opens up any design that you want to make.